Hello, dear students. Let's start the new chapter. Chapter number 9D, Unsaturated Hydrocarbon Alkynes. This chapter from the class 10th in subject chemistry. Let's open your chemistry book and come on the page number 249. Now, introduction about the alkynes. Alkynes are unsaturated hydrocarbons which contain at least one carbon-carbon triple bond in their molecules. So triple bonds is present in the hydrocarbons between the two carbon of the molecules, that all hydrocarbons are called the alkynes. The general formula of the hydrocarbons alkynes is CnH2n plus CnH2n minus 2 CnH2n minus 2. The first and the most important member of the alkynes is acetylene or ethine, CH triple bond CH. So alkynes are also called the acetylenes due to the first important member, acetylene. It's called the acetylene. Alkynes are also called the acetylene. Now the homologous series of alkynes. If the carbon 2, then it is called, IUPAC name of the alkynes is ethine. Eth is the root name for the 2 carbon and ine is the suffix for the alkyne. Common name of ethine is acetylene. Molecular formula C2H2, condensed formula CS, triple bond CS, and this one is the structural formula. If the number of the carbon is 3, then IUPAC name is propyne, prop root name for the 3 carbon. Common name is propylene. Molecular formula C3H4, condensed formula CH3, C triple bond CH, and this one is the structural formula. If the number of carbon is 4, then there are 2 isomers. The 4 carbon of alkyne is, one is the 1-butene, it is called the butylene, C4H6, and their condensed formula is CH3CH2, C triple bond CH, and this one is the structural formula. Now the another isomers of the butene is 2-butene. It is also called the butylene, common name. Molecular formula is similar, and the condensed formula CH3, C triple bond C CH3, and this one is the structural formula of the 2-butene. Now isomers of alkynes. Alkynes with 4 or more than 4 carbon atoms can form isomers similar to the alkenes. As for example, in case of butene, butene has the 2 isomers, 1-butene and 2-butene. Now the sources and occurrence of the alkynes. Source of alkynes is natural gas and petroleum. Traces of ethine is present in coal gas and in gas obtained by decomposition of certain organic compounds. So the main source of alkynes are natural gas, petroleum and coal gas. Now the first member, ethine, this is also called the ethylene, C2H2 formula. Preparation of ethine. The laboratory preparation of ethynes from calcium carbide. So the reactants are used in the laboratory preparation of ethynes are calcium carbide and water. So when calcium carbide react with water to form the acetylene and calcium hydroxide as a byproduct. Now the procedure. First take few pieces of calcium carbide in a conical flask and add few drops of water through the Tisdale funnel. by the reaction of calcium carbide with water to produce the acetylene gas, and this is also a type of exothermic reaction. Let's see the diagram apparatus that used in the laboratory for the preparation of acetylene. First, this one is the beaker, the conical flask that containing the calcium carbide, few pieces of the calcium carbide, and added the water into the calcium carbide into the beaker with the help of Thistle funnels, and then it produces the acetylene gas, and that ethylene gas is passes through the delivery tube into the acidified solution of the copper sulfates, and the acidified solution of the copper sulfate absorb the many type of the impurities that present in the mixture of the acetylenes, and then the acetylene passes through the delivery tube into the inverted gas jar, and acetylene collected by the downward displacement of the water into the gas jar. So collection of gas is collected by the downward displacement of water since it is insoluble in water, so it can be collected by the downward displacement of water. Now the purification. So evolved acetylene gas usually contaminated with a small amount of the phosphine, arsine, ammonia, hydrogen sulfide, etc. These all impurities present along with the evolved acetylene gas. So first our duty to remove the acetylene gas impurities from the acetylene gas. So in order to remove these impurities, the evolved gas is passed through an acidified solution of copper sulfate, and that copper sulfates absorb the phosphine, arsine, ammonia and hydrogen sulfides, and pure acetylene gas that is obtained is collected by the downward displacement of water that you have seen in the diagram. Now another methods for the preparation of acetylene is by dehydrohalogenation of 1,2-dibromoethane. So acetylene can also be obtained by treating 1,2-dibromomethane or ethylene bromide with a hot and concentrated alcoholic solution of potassium hydroxide. So let's see the reaction. When 1,2-dibromomethane react with the alcoholic solution of KOH, then the Br molecules, both Br molecules get removed one by one, and also the one hydrogen molecule from each carbons removed by the alcoholic KOH to form the ethene or acetylenes, and produces KBr and H2O as a byproduct. Now another method is by pyrolysis of methane. So when methane is heated to about 1500 degrees Celsius in absence of air, then ethane is formed. Let's see the reaction. When pyrolysis of ethane at 1500 degrees Celsius, then it produces the ethane gas and hydrogen also. Now by the synthesis methods, Berthelot synthesized acetylene by striking an electric arc between graphite electrodes in an atmosphere of hydrogen. So Berthelot synthesized the acetylene gas by striking off the electric arc between graphite electrodes in the atmosphere of hydrogen to produce the acetylenes. So the carbon electrode graphite, which is made up of the carbon, and by striking of the graphite electrodes in the atmosphere of hydrogen at the temperature 1200 degrees Celsius, it produces the ethylene gas in the electric container. So this is all about the preparation of the acetylene and their introduction. Okay, thank you. Thank you for watching this video.